Hello and Assalamualaikum to all panelists and viewers for my video presentation. This video is in purpose to present about my final year project with project title of IoT based muscle fatigue monitoring system. My name is Amirah Binti Hazlan and I will be the presenter of the video. My supervisor is Associate Professor Dr. ZULKIFLI Muhamad. Please enjoy my video. Project Introduction. Essentially, any physical activity involves injuries. Muscle injuries are prevalent among athletes and have a major effect on the accomplishment and performance of an athlete. With proper stretching and warming, muscle injuries can be avoided. However, muscle fatigue may also occur. The physical condition of individuals, in particular sportsmen, is extremely difficult to track. In this project, muscle fatigue can be monitored using internet through a mobile application. Blink application will be used, which is majorly utilized in developing new IoT Internet of Things system. The complete system is composed of a power supply, EMG sensor, ESP32 LoRa Wi-Fi module, and microcontroller. This technology is suitable for monitoring fatigue condition, which is used to real-time monitoring of fatigue for sports person. So, this video will present the development of a muscle sensing system for the purpose of tracking muscle fatigue in sports activity. This part will be explained about problem statement. Most of the athletes experience muscle fatigue during their training days. Thus, it can give a big impact on their performances and training. Nevertheless, to track the athlete's physical condition is challenging and because they cannot estimate on how far their injury can be. Despite there are some other systems that can monitor muscle fatigue, most of it only can be monitored using PC. It is difficult for coaches and athletes to monitor muscle performance from getting injury because most of the systems nowadays are not portable. Since the athlete need to train in various places, a monitoring system that is portable with all the smartphone and device are suitable to be used. The objective of the project is the first one is to develop a muscle fatigue monitoring system whether a trainer or athletes can monitor and track their muscle performance and injury using IoT mobile application approach. Second one is to create a user interface that is easy to monitor muscle fatigue and user friendly. The third one is to test the performance and efficiency of the system. So, for the literature review parts, it contains 5 subtopics, which is previous studies, definition of IoT, muscle fatigue detection, mobile platform monitoring, and the last one is microcontroller ESP32. Previous studies. The first research stated that their goals of the project are to detect muscle fatigue and develop monitoring system for swimming athletes. Thus, athletes trainer will be in ease to monitor their muscle fatigue and injury. EMG sensor were used in swimming athletes while practicing some movement during swimming. In this research stated that the constructing monitoring system development is efficient to detect muscle fatigue among swimmers with the waterproof features in AMG sensor that have been used in it is increasing the enhancement of the monitoring system and it's wearable and easy to monitor muscle fatigue condition during training for athletes. Another research is about development on SMEMG monitoring system using smartphone and maintain biceps from getting muscle fatigue. The system has been proved that it is helpful to maintain biceps and avoid muscle fatigue during training and exercises. Besides, by using wireless technology, which is Hypertext Transfer Protocol (HTTP), the Android smartphone can record and transfer as EMG signal to personal computer (PC) easily. Next, we move to definition of IoT. The Internet of Things is a network of physical objects, technology, and hardware to communicate. Kevin Ashton described IoT as a network with radio frequency identification (RFID) technology of uniquely addressable and interpretable things. IoT's fundamental concept is to enable an autonomous exchange of useful information between various uniquely identifiable real-world devices that are invisibly embedded. IoT technology has been used widely in sports and health sectors. IoT systems may be used in patients that need continuous treatment for remote physiological status monitoring. The convergence of different IoT architectures have recently enabled the development of intelligent healthcare systems. IoT-based technology also helps the development in monitoring patient and treatment more efficiently and can predict the symptoms before starting diagnosis. Vital health signs can be captured by using medical sensors and wearable devices. Moreover, heart rate, blood pressure, body temperature, blood glucose, and muscle fatigue can be monitored by using IoT. Muscle fatigue detection. Muscle system is the largest system in human body which is contribute about half of our body weight. Muscle fatigue usually happens due to lack of blood oxygen and nutrition present in the muscle cells. In addition, prolonged or repetitive work can increase the emission of lactic acid and accumulated in our body muscle system. The demand for oxygen gas during high-intensity exercise can be greater than the supply, thus decreasing blood flows through the muscle. Nowadays, with the rise of technology in sports sectors, EMG sensor has been used widely in terms of reducing issue and muscle injury by sports coaches, especially during sports training and also increasing sports player performances. In order to monitor muscle fatigue by using EMG sensor, EMG sensor will detect signal from muscle activities and collect data of amplitude and frequency by using electrode that attach on the skin through muscle surface detection. The advantages of using EMG sensors are able to monitor muscle fatigue in real time during training and non-invasiveness. Moreover, it can be monitored the muscle fatigue of a certain muscles that is highly correlated with biomedical and physiological changes in muscle during fatiguing. Mobile platform monitoring. Nowadays technologies, it is a trend that every appliances or system can be monitored through mobile applications. One of the applications that can be used in mobile monitoring is Blink. Blink application is a platform for smartphone apps that can control Arduino, Wi-Fi module, and Raspberry Pi and other boards across the internet. Blink was designed to control hardware remotely, display sensor data, store and visualize data. Blink operates by pressing the blink button and sending a signal to Blink Cloud in order to locate connected hardware by means of an authentication key. The message is then forwarded to the hardware. When obtained by the hardware, the software will function accordingly. Blink application is user-friendly and simple to develop. The user interface microcontroller ESP32. A microcontroller is an integrated circuit device that was designed to a specific function in an embedded system. Microcontroller are also used in controlling other parts of electronic system, usually through microprocessor unit, memory, and RAM. For this project, ESP32 is being used as a microcontroller. ESP32 is a microcontroller board that can connect with various types of sensors in one time. In addition, ESP32 is a competent wireless programmable microcontroller board that can unloading Wi-Fi networking functions from other application processor or hosting an application. The best thing about ESP32 is that it has two-core processor and support Bluetooth 4.2. Generally, ESP32 operates with 2.2 to 3.6 volt voltage range and able to clock frequency up to 240 MHz with 512 KB RAM and low power usage. However, for this project we'll be using ESP32 TTGO LoRa, which is actually have the same function as standard ESP32, but it has a built-in LCD display on it, and it will be more easier to conduct monitoring purposes. For the scope and limitation of the program, the scope of the project is to develop a master fatigue monitoring system by using Internet of Things and can be monitored in real time by using ESP32 and Blink application. The master fatigue system gather data from EMG sensor and then transferred to Wi-Fi module, which is ESP32. Then the data will be generated and transferred to Blink application and displayed the master activities. The limitation of the project are: first one is integrating master fatigue monitoring system using ESP32 and Blink application. The second one is developing an algorithm for the ESP32 in order to monitor master fatigue and prevent muscle injury from happening. The third one is use a mobile application that can be used to monitor muscle fatigue and prevent the occurrence of muscle injury using smartphone via Blink application. For methodology part, this is the flowchart of the system. The first one, I start with literature review and then identify problems of the system. Then select suitable component for the system. Next, design circuit diagram for the system. And then surveying main components for the system. And then I proceed with developing algorithm for the system by using Arduino IDE. Next, I will upload algorithm to Wi-Fi module. If not successful, I will proceed with developing algorithm for the system by using Arduino IDE. If successful, I will continue with design prototype, making result and discussion, and also conclusion. For this project, the hardware that is need to be used consists of two main parts, which is microcontroller or Wi-Fi module and sensor. The microcontroller will perform as a data processing tool and can unloading Wi-Fi networking functions from other application processor or hosting an application, while the sensor is used to provide proximity measurement. The picture shown on how the monitoring system works. After the program from Arduino IDE uploaded to microcontroller, which is ESP32 TTGO LoRa, the system can be functioned. EMG sensor will detect signal from muscle activities and collect data of amplitude and frequency by using electrode that attach on the skin. Then, the data will transfer to ESP32 TTGO LoRa via Wi-Fi. Then, Wi-Fi module will transfer data to Blink Cloud, then send to Blink application and convert it into form Blink interface for monitoring purpose. To maintain the muscle performance of the athlete, a real-time monitoring system is done by measuring the voltage transferred from the EMG electrode to LCD display of ESP32 TTGO LoRa Wi-Fi module microcontroller and Blink application. The picture shows the illustration of the circuit diagram. The ground pin and VCC pin of EMG sensor are connected to ground and 5V respectively at TTGO LoRa, while SIG pin are connected to pin 35. For software, I will be using Arduino IDE for system programming. The picture shown Arduino IDE that will be used to develop coding for microcontroller ESP32 and connect Blink application. Arduino IDE software will be used to develop algorithm of the system and integrating Wi-Fi module and Blink application. This project requires to install libraries for Blink and ESP32 in order to develop two system coding. Arduino IDE use C and C++ language using special procedures of coding structuring. The algorithm is configured so that TTG Aurora ESP32 can connect to Wi-Fi and work together with smartphone via Blink application. Blink application also as one of the software will be used. The widget in Blink application is easy as we can drag and drop the widget and are already provided. With a simple interface, it can help to make monitoring work more easier and reduce possibilities of muscle fatigue. Last but not least is expected result for this project. The first one is this project is able to become portable monitoring system that can monitor through mobile application. Next, I managed to develop a muscle fatigue monitoring system that is more convenient and efficient by using IoT system. Last one is able to display real-time monitoring data to users. That's all from me for my final year project presentation. If there is any question regarding to this video, please don't hesitate to drop your message. Thank you for your time.